Hello, good evening, everyone. You're welcome to today's live stream. Okay, so we are going to be discussing projectiles. But I will give you a few minutes to see if one or two people will come online before we start the class. Stay tuned. All right. Today we are going to look at projectiles. What is a projectile? Now, there's a common experience that if you throw an object, or for example, a football, it's going to move this way and form what we call a parabolic path. For example, this is where the point is, right? An object is here, this is the horizontal ground. Now, if you throw a football up, it's going to move and go to this certain point, then it returns to the ground. This object that is being thrown is said to be a projectile. Okay? But the object on its own is not a projectile, except it is thrown. Now, if you ask what is a projectile becomes that object that is thrown and it's allowed to move freely on its own under the influence of gravity. What do I mean by that? Once that object is thrown, it's going to move and form this path, then return to the what? To the ground. Do we understand? Now let me define what is a projectile. So we we can say that a projectile is an object that is thrown upwards and it is allowed to move freely under the influence of gravity. Now, and I said before that this object that is thrown becomes a projectile. For example, a thrown football, a thrown shot put, a fired bullet. The object on its own cannot be characterized to be a projectile except it is thrown. It will not make this movement of what we call parabola or trajectory, right? So we cannot say that the movement of a projectile is said to be what? Parabola. So let me write. The path or movement of a projectile is called parabola, or we can say trajectory. Now see the movement. The object moves this way and return. This path or this movement is what is said to be what? Parabola or trajectory. So this is the path taken by a projectile. This is the path taken by a projectile. So I'm still going to explain this motion of a projectile very, very well, right? Now we have examples of projectile in sports and in warfare. So it can be experienced in sports activities. It can also be experienced in warfare activities. So I'm going to list all of them and still explain what we mean by the aspect of projectile in sports and in warfare. Okay, let me see if we can capture everything. We have in sports, we have some examples. Number one, a thrown shot put. a thrown discus, an athlete doing the high jump. Now we can say in warfare, okay, a bullet fired from a gun, a stone released from a catapult, then a fire sphere. Now, looking at these examples of projectile, this is the aspect of this projectile in sports. Now, this sports, we can also include a thrown football, okay? Now, we have a thrown shot put, a thrown discus, an athlete doing the high jump, okay? Now, once this is into motion, the object must move in parabola. The object must move in parabola. And parabola means trajectory, right? It will return to the same level from which it was projected. Okay? So now, looking at the warfare, we have a bullet fired from a gun, a stone released from a catapult, then a fired sphere. This one, the object too must perform this movement. The object too must take this shape of a parabolic path for it to be said to be a projectile. Now, don't forget that if this object is not thrown, for example, if you say a stone on its own that is at rest cannot be considered to be a projectile, except it is made to be in motion when it is being thrown. I hope you understand. So, a bullet on its own that is inside a gun cannot be assumed to be a projectile except it is being what? It is being fired. It becomes a projectile. So don't mix it up. And this object, when it is being fired, it's moved freely on its own under the influence of what? Gravity. So I'm going to make illustration of the path or the motion of a projectile so that we can see the relationship between this and the movement made by this projectile. Okay, so let's look at what we have. Now, if you see this is the motion of a projectile, how do we explain it? Now, this object here, this is the point of origin. If this object is thrown up, it's going to move and get to this certain point. That is the maximum height at which the object will reach before returning to the ground. So the object will move from here to here, right? Now, from this highest point to the horizontal, from which the object was projected, is said to be the maximum height. So this is H max. Now, the object has to return back to its original what? Level from which it was projected. There are things we need to consider if you are considering projectile. The first thing you are going to consider is the time. This time taken for this object to move from here to reach to the maximum height. And also, the time taken from here to return to the ground. For example, if this object takes 2 seconds, guys, see, to get to the maximum height, now it's still going to require it to take another 2 seconds to return to the what? To the ground. So if they ask to calculate the total time taken by this object to move and return to from the point, to return to the point from which it was projected, is going to be these 2 seconds here plus another 2 seconds here. That will give me what? My total time of flight. Now, we are also expected to know the maximum height from which the object has reached. Then we are also expected to know range. What is range? Range is the horizontal distance from the point of projection. This is where the object was projected. For example, I want to project an object and this is where I was standing. So this is my point of projection, right? It will now move and return to the ground. So for you to record the distance from here to here, it is said to be what? Range. And range is otherwise known as horizontal distance. And don't forget that as this object is making movements, it has what we call an angle of projection. So for that object has moved, we have the angle of projection. So I'm going to explain to you what is the time of flight, what is the maximum height, and what is range, and the relationship between them and each other, and how we can solve problems with them. So let's look at the definition of terms. terms used in describing projectile. The first one is time. What is time? This is the time required. This is the time required. Okay, sorry. I'm saying required. Okay, I can just say this is the time to reach the maximum height. Like I explained to you before, that an object, we have to note the time required for it to reach the maximum height from which it was projected. Okay? Now, if the object, this is the object where it was projected, and it moved from here and get to this certain point. So this is what is said to be what? The t you are looking for. So this is the time taken for it to reach here, the maximum height, right? And we have made respect of what? The angle. This equation was gotten from equation of motion under gravity, okay? Now, we have the equation of time as use sine theta over g. We are making respect of this angle because the object is in motion and makes a parabolic path, okay? Now, it is measured in seconds, sorry. This is seconds. This is also seconds. It is measured in seconds because it is time. All right. Now we have the time of flight. This is the time required for a projectile to return to the same level from which it was projected. Now, this one is different from this time. This time in particular is just the time for it to move from here to here, right? But if you are considering the time of flight, that means it is total time. It's the time required for the object to reach here and also return to the what? To the ground. So if it takes this object here 1 second to reach the maximum height, is it going to take it another 1 second to do what? To return to the ground. So we can say that the time of flight is the total time. It's the same thing as saying this is 2t, right? Because it is twice the time to reach the maximum height. Now, what can we say? Now, if we say it is twice the time to reach the maximum height, we can now say that t is equals to, capital T is equals to 2t, and is equals to, since this small t is u sine theta over g, we are going to say this is 2 u sine theta over what? G. Because it is time, it is measured in seconds. I hope you understand. Let me explain it again by saying that this time is the time required for an object to reach the maximum height. And the maximum height is just from here to here. We are not considering the whole movement of an object. Now, if you look at the time of flight, it's 2 times of the time to reach the maximum height. That means we are considering when the object has moved from here to the what? To the ground. So anything you have here, let's assume my time is 1. So my time of flight becomes what? 2. Because it's 2 times 1. Hope you understand. And let's also assume that my time is 2. My time of flight will now be what? 2 times 2 to give me what? 4 seconds. You understand? So let's look at the maximum height and the range. All right, the next thing we are going to look at is the maximum height. This is the highest vertical distance attained as measured from the horizontal projection plane. So this is my projectile, okay? This is the vertical distance, right? Attained as measured from the horizontal projection plane. So if you measure from this projection plane to the highest point, we now call it to be what? My maximum height. Okay? And this maximum height is measured in meters because we are dealing with distance. It is measured in meters. The magnitude of this is u square sine square theta over 2g, right? Now, this sine square theta, is the same thing as saying sine theta all squared. So don't get it confused. This sine square theta is the same thing as this, right? Now, after getting your theta, you now put it here and get the sine. Whatever two you have, you're going to square it to get your what? Sine square theta. Because this is an angle, and this is how it is agreed, or this is how scientists say we should represent when we want to square what? An angle. This is how it should represent. So this is equals to what? This. This is equals to this, right? So once you square, you get the sine of your angle, then you square whatever thing you have. That is your sine square theta. Then divided by 2g. We already know what is g. This is acceleration due to gravity, and u is initial velocity. I'm still going to explain all of that one again. Now we have the range. The range is the horizontal distance from the point of projection to the point where the projectile hit the projection plane again. Now, if I use this illustration to explain the range, this is the point from which an object was thrown. This is the point at which a bullet was fired. This is the point at which an athlete started the high jump, right? So now, if the bullet move and return to this ground, okay? So if we measure the horizontal distance from here to here, we call it what? Range. I hope you get it now. And because it is a distance but horizontal, it is measured in meters. Now we have that from here to here becomes my what? My range. Whereas from here to here becomes my what? My maximum height. Now from here to the point at which an object returned to the level from which it was projected is said to be time of flight. Then for the object to move from here and get to the maximum height is simply said to be time. So these are the four things that help us to explain the projectile proper. Now, the magnitude of the range is equal to u square sine 2 theta over g. Square theta, 2 theta means, let's assume that your angle is 30. This is 2 times what? 30. So what you're actually looking for, you're looking for sine what? 60. So it's different from this, right? In this one, you're going to get your theta and get the sine before you square it. But here, you're going to multiply your angle by 2 first before you find what? The sine of it. Do you understand? All right. So let's go to the next one. If you are just joining us, just give it a thumbs up, okay? Give this stream a thumbs up. So let's proceed. Now, range is maximum. When the angle of projection is 45 degrees. Range is maximum when the angle of projection is 45 degrees. So what do I mean by that? I have R max is equals to U square sine 2 theta over G. Now, if we say that this is maximum range, it means that my theta becomes 45 degrees. I'm going to put 45 degrees there to see what I'm going to come up with. I have R max is equals to U square sine 2 times 45 over what? G. Okay? So R max is equals to U square sine 2 times 45 is 90 all over G. But sine 90 is equal to what? 1. That means at maximum range, you're going to have U square over G. That is only at maximum range. So don't forget that at maximum range, the angle of projection is equal to 45 degrees. All right. So if we go by that, let's take our parameters well. We say that U is my initial velocity. Okay. What's my theta? Is angle of projection. Angle of projection. There was my G. Acceleration due to gravity, right? Now, this is what we mean by that. Now, the range is said to be maximum when theta is 45 degrees. If you are given a problem and you ask to find the maximum range, simply put theta as 45 degrees and solve, or simply use this formula U square over G. So we are going to look at a few examples on this to see how we can apply the formulas of what we just did now. The time of flight, the maximum height, and the range. All right, let's look at this example. A projectile is fired with initial velocity of 100 meters per second at an angle of 30 degrees with the horizontal. Calculate the time A, right? B, the time of flight. C, the maximum height. And D, the range. Now, looking at this question, we are going to use the illustration to explain it. Then we can now solve. Now, if I want to draw a projectile, I will say this is a projectile, right? Now, this projectile is fired with an initial velocity of 100 meters per second. So it's moving with a velocity of 100 meters per second at an angle of 30 degrees with the horizontal. So the angle that is here and is touching the horizontal becomes 30 degrees. We are asked to calculate. One is the time. Which time are we looking for? Is the time required to reach the maximum height. So we are looking for number A, the time to reach here. Then the time of flight becomes the time to reach from here to return to the same level from which it was projected. So if you get this time, you multiply by 2 to get my total time, which is the time of flight. Then the next thing you are going to look for is the maximum height from here to here. Then the last thing becomes the range. This is the range covered. Okay, so this is the illustration of this question on the board. So I'm going to start solving them one after the other. We are going to state the parameters we have. Solution. Okay, I have initial velocity u to be 100 meters per second. Then I have the angle of projection theta to be 30. Then acceleration due to gravity g, which is a constant, is equal to 10 meters per second squared. Now, going by this, we are going to put in our parameters and see how our answer will come up. So the first one is the time. And the formula for the time, which is small t, is equals to u sine theta over g. Okay? So going by that, my u is 100. I have 100 sine. What is my theta? My theta is 30. Then divided by what? My g is what? 10. Then I work it out by saying this is 100 times. We already know that sine 30. Even if you don't know what is sine 30, you can use your calculator and find out. Sine 30 is 0.5. I'm going to say 0.5. Okay? Divided by what? Divided by 10. Now, 0 can cancel 0 here. Okay? So if we say 10 times 0.5, 10 times 0.5. Okay? If you don't want to use calculator, this one will cancel this, right? So the answer becomes 5. If I want to explain it more, that means I have to change it to standard form. Okay? If I say 10 times 0.5, right? 10 is the same thing as 1 times 10 raised to the power of what? 1. Then times 0.5 is the same thing as 5 times 10 raised to the power minus what? 1. Right? Okay, let me work on the whole numbers. 1 times 5 is what? 5. Okay? Then, if I want to work on the powers, I will have 10. From the law of indices, the bases are the same. I'm going to add the powers by saying this is plus 1 minus 1 is going to give me what? 5 times 10 raised to power what? 0. And also from the law of indices, anything raised to the power of 0 is equals to 1. So we can say that our time is what? 5 seconds. I believe you understand. Let me bring it down by saying that my time is 5 seconds. But then you can use your calculator and just multiply it from here and get your answer. But in case you don't have a calculator, you still want to know how I got my answer as 5, I now change it to standard form. I use the law of indices to work on the powers, and I still get the answer as 5 seconds. I hope you understand that. So the next thing we are going to do is to get the time of flight. The time of flight. So let's go to the time of flight. Now for us to get the next one, which is the time of flight, that is my B. I'm going to say time of flight T is 2 what? 2T. Or you can still say 2U sine theta over G. I've already gotten this to be 5. Simply put it inside here and multiply by 2. That gives us our answer by saying that T is equals to 2 times 5, then T is equals to 10 seconds. Remember that the time of light is twice the time to reach the maximum height. Now, if we take an object 2 seconds to get to the maximum height, it's going to take that same object 2 seconds to return to the ground. So if you add the 2 times together, that becomes the total time taken by this object. So once you have gotten the time to reach the maximum height, just multiply your answer by 2. You are going to get the total time of the object, which is the time of flight. Now the next on the line is the maximum height attained. Maximum height attained. That is the next question I'm going to solve now. Okay. The maximum height, that is C. The formula H is equals to U square sine square theta over 2G. So let's put in what we have. My U is 100, so I'll have 100 square sine. This is sine 30 all squared, all over 2 times 10. Okay, so let's bring it out. You say H is equals to 100 square is the same thing as saying 10,000 times sine 30 is 0.5. I will say 0.5 all squared. Okay, then divided by 2 times 10 is 20. So what do we have here? We have 10,000 times 0.5 squared. We can use our calculator by by saying 0.5 square, our answer will give us what? 0.25. I have 0.25 divided by 20. Okay? So what you're going to do now is to multiply by saying this is 10,000 times 0.25. Okay? So we have 2,500. So this is 2,500 divided by 20. So divide our answer by 20. My answer becomes 125 meters. Hope you understand that. Now, the formula is H is equals to U square sine square theta over 2G. And I explained to you that this square theta is the same thing as saying sine theta, you now put what? Square. Because it's a trig and it's an angle. So we cannot just put square. We can't just write it this way. Okay? No, so this is how we normally represent an angle when you want to square it. So we have to substitute. My u is 100. I'll now square it. Bracket. This is my sine theta, which is sine 30, all squared. Then divided by 2 times, my g is constant, which is 10. Right? Now what I'm going to do next is to substitute it what I have. When you square 100, something as having 10,000, then times sine 30 here is 0.5, all squared. Now we divide by 2 times 10 is 20, right? So let's open this and get what we have. So this is 10,000 times, the square of this is going to give us 0.25. Now divided by 20. Now what do we have next? We have h is equals to 2,500 over 20, and my answer becomes 125 meters. So this is how we can solve that to get our answer, which is the maximum height attained. So the last we are going to look at is the range. Okay? So if you are joining us, please give this stream a thumbs up. Thank you for joining this class. Okay, so the last one is the range. Let's look at the range. The range is equals to u square sine 2 theta over g. U square sine 2 theta over g. Okay, what's my u? My u is 100 square sine, this is 2 times 30, then divided by what? 10, right? Now 100 square is 10,000 times, this is 2 times 30 is 60 divided by what? By 10. Let's work it out by saying this is 10,000 times sine 60 is going to give me 0.866, then divided by what? 10, right? This 0 cancels 0, and I have range is equals to 1,000 times 0.866. Okay? So I can use our calculator. 1000 times 0.866. So my answer is 866 meters. Now let me explain how I arrived at that particular answer. This is my range, and the formula for range is u squared sine 2 theta over g. Students used to misplace these things. Some people will now use 2 theta in place of square theta when it comes to maximum height. Please, it's only range that has 2 theta, right? So this is u squared sine 2 theta over g. What is my u? My u is already 100. That is 100 squared sine 2 times 30, because my angle is 30. Then divided by what? By 10. Alright? So I have r is equals to 100 squared is 10,000 times sine 2 times 30 is 60. Divided by what? 10. Now, this 0 can cancel this 0 up. So I'm left with 1,000 times 0.66. By the time you multiply, you're going to have what? 866 meters. So this is how we have obtained our range. So this is how we can solve problem on projectiles. I hope you understand this now. Now, projectile can also come in form of horizontal and vertical projection. That is a situation whereby an object is projected vertically, right? And also a situation whereby an object is projected horizontally. So I'm going to treat the two concepts so you can understand that when a question is given to you, you understand where the question is actually going to. If you are working on the normal projectile or vertical projectile or horizontal projection, now you should know which particular one that the examiner expected you to know, so that you can know how to tackle the problem and you get your answer correctly. So the next thing you're going to do now is vertical projection. All right, so we have vertical projection. Vertical projection. When an object is projected vertically, it means that the angle of projection is 90 degrees. Now, let me explain with a diagram. This is an object, okay? Then this is a horizontal ground where the object was, where the person that is throwing the object is standing. Now, I said before I explain, when an object is projected vertically, it means that the angle of projection is equals to 90 degrees. Now, this is the horizontal ground, and I choose to project this object up this way, right? It will go and reach a certain height, it will return to the what? To the ground. So as the object is going up and coming down, I'm considering vertical projection. Hope you understand. I'm considering vertical projection because the object is going up and coming down. And if I throw this object up, it will reach a certain height and return to the same level from which it was projected. Now, the object goes this way. This is the highest point. The object went up and came down. Okay? So if it takes this object 2 seconds to get to this highest point, it's going to take it another 2 seconds to return to the what? To the ground. I've explained that before. So that is just time. And the time of flight becomes this time plus this time added what? Together. So it's going, if it's going to take it 2 seconds to go to the vertical height, it's going to reach the vertical height, it's going to take it another 2 seconds to return to the ground. So that is what we have. So considering this, the direction of the movement of this object and the horizontal ground, we now say that the angle of projection is what? 90 degrees. And if the angle of projection is 90 degrees, we are just going to consider 3 things in this vertical projection. What is the first thing we are going to consider? We are going to consider the time to reach the maximum height, which is time. Okay? So the first thing we are going to consider is time. That is t. And I told you that the formula is what? U sine theta over what? G. But here that our angle is now equals to 90, what are we going to say? You know that sine 90 is equals to 1. So we now say, okay, this is U sine 90 over G, right? Because once you're considering vertical projection, your theta becomes 90 automatically because that forms an angle of right angle. An angle of right angle is an angle of 90 degrees. So what I'm going to do, we now say, but sine 90 is equals to what? 1. So if sine 90 is equals to 1, automatically my t becomes u over g. And this can also only go for vertical projection. If the question did not specify that an object was thrown vertically, don't use u over g. Do we understand? It's only when an object is projected vertically that our theta becomes 90 degrees. But if it is normal projection, that means that my theta becomes the angle given to you. Okay? So the sign becomes u sine theta over g. Do you understand? All right. So the next thing we are going to look under this vertical projection becomes what? The time of flight. We are going to look at the time of flight. All right, then the time of flight becomes, that is B. That is capital T. Remember that this is my what? 2 small t. So my time of flight becomes 2u over what? G. Becomes 2u over G. It must only be from vertical projection. It must only be from vertical projection. Okay? So since my angle is equals to 90 degrees, most of the sine will go. So we are left with what? This. All right. So the next I'm going to look at becomes my height. Now the height is equals to u square sine square theta over what? 2g. Okay, so let's substitute by saying this is u square sine 90 all squared divided by 2g, right? But sine 90 is equals to 1. If sine 90 is equals to 1, everything automatically becomes what? 1. So my height is equals to u square over what? 2g. Okay? So at vertical projection, we have that my height is equals to u square over 2g. So we have these three things you have to consider when you're considering vertical projection. First is the time, second is the time of flight, and third is the maximum height. So let's solve a problem so that we can understand how we can use this to answer our question. Okay, let's look at this question. We know that our G is always constant. That is 10 meters per second square. All right. The first thing we are going to do now, let me divide the board. The first thing we are going to do now is to get the time, which is A. The time is 1t. And because they say that the object is projected vertically, it means that the angle of projection, theta, is equals to 90. So I'll say theta is equals to 90. So we don't need to put the value of theta again. So I'm going to have what? U over what? G. Right? So what is my U? Initial velocity is what? Is 5. I say this is 5 over what? 10. Right? Now let's divide it. 5 into itself 1. 5 into this is what? 2. So when I divide it, I'm going to have 0.5 seconds as my what? As my time. So the next I'm going to do now is to get the time of flight. That is 2u over what? G. So what do I have? I will say 2 times 5 all over what? 10. Right? 2 into itself 1. 2 into 5, I have 5. 5 cancel itself 1. 5 cancel this 1. So my time of flight becomes 1 second. Then the next thing we are going to do is to find what? The maximum height attained. And that maximum height attained, h, is equal to u square over 2g. Right? Okay. What's my u? My u is 5. I say 5 square over 2 times 10. Okay. So what is 5 square? That is 5 times 5. That is 25. 25 over 20. Yes, something can go. 4 can go. Or rather, 5 can go. 5 into this. 5. 5 into this. 4. So my h is equal to 5 over 4. Now we can divide with our calculator to have 5 divided by 4. So my answer becomes 1.25 meters. My answer becomes 1.25 meters. So you can now see how we can solve this problem on vertical projection. So far that the angle is not there, a seminar must specify what you want you to use and solve. So this is how we can solve problem on vertical projection. So let's dive into horizontal projection. you are just joining us, just please give it a thumbs up. And if there is any topic you have challenges in understanding in physics and you want me to explain it for you, you can write it in my comment section and tell me, please, I should teach that particular topic. Okay. All right. So let's proceed to horizontal projection. Horizontal projection. Now, when we talk about horizontal projection, one thing will come to your mind. What is that? Horizontal. How? How can the object be projected horizontal? Now, for an object to be projected horizontally, it means that this particular object must be projected from a certain height for it to move horizontally. That's what they mean. Okay? Normally, as I'm standing on the ground now, if I project an object, it will move from here to here, right? That is normal projection. But if I stand on, let's assume this is a tower that has a certain height. If I project object and this is the human being, this is the boy standing here, okay, I want to project a stone. If I project this stone while standing on the height of this tower, or while standing on top of two-story building, or on a height, what am I going to do? If I throw that object, it's going to move this way and return to the what? To the ground. That becomes horizontal projection, right? Because the object did not start from here to move. The object started from here and it will go horizontally this way and now fall to the what? To the ground. In this concept, it is agreed and it is considered to be what? Horizontal projection, right? Okay, so in horizontal projection, so many things is kept into consideration. Now let's look at the diagram. All right. All right. So if you are considering the angle of projection, you're considering the angle of projection here under horizontal projection. We don't normally use the angle to solve, but since the object has made some movement, we now have that. We extend this point to this point, we can form an angle called theta here. But I just want to generate what actually we are going to looking for in this horizontal projection. Now I said that the object was projected from this certain height. This is the height of a tower, and this is the boy that projected this object. This is the stone. So this stone will move from here and return to the what? To the ground. So the boy was standing at a certain height. Okay? Now, from the point of projection, this is the point where the boy was standing, and this is where the object returned to the ground. It is assumed to be my horizontal distance, and my horizontal distance is said to be the range. Now, for us to generate formulas we are going to use to solve this, we are going to use equation of motion under gravity. And if you are considering horizontal motion, gravity has no effect on this, right? It means that my acceleration due to gravity g equals 0. So what am I trying to say? Using h is equals to ut plus half gt squared. In horizontal projection, my g equals what? 0, because the object is not going up. I told you earlier in my previous class that when an object is thrown up, it is affected by the force of gravity, right? So that is why when an object is going up, it is moving against the force of gravity, because gravity acts down. So, but the object was acting up. But if this object is falling down, it is moving towards the force of gravity. All right. So if you're using the equation of motion under gravity, it means that my g becomes plus when it's coming down, while my g becomes negative when it's going up. All right. But here we are considering horizontal motion. It means that my acceleration due to gravity becomes 0 because the object was not going up or coming down. So using this equation of motion under gravity, we have h is equals to ut plus half gt squared. Right? Now, we now consider that this g is equals to what? 0. If this g is equals to 0, automatically this equation goes to what? 0. So we are left with h is equals to u what? ut. Now, what is this h? This h is what? Is the height. What is this u? This u is the horizontal velocity from here to here. What is this? This is what? The time, which is time required for it to return to the what? To the ground. Now, we can use this to solve this. We can use this to solve this. We can also use the other one to solve this. All right, I hope I'm not. Okay, sorry, there is a mix-up. Sorry. Pardon me for that, please. There is a mix-up somewhere. All right, let me go again. Using h is equals to ut plus half gt squared, right? Okay, so if you are considering horizontal motion, my g remains because the object is going down, so it's not equal to 0. That was a mistake, sorry. So, but my velocity here is equal to what? 0. So my initial velocity here is equal to 0 because I was using motion under gravity, right? But this object was not actually what? Going up. But you remember that what I did previously, I have this. Okay, so this is this, and this is this. If an object is going up, my A is equals to minus G. This is the highest point. My V is equals to 0. But if an object is coming down, U is equals to 0, and A is equals to plus G. So if I'm using that, that means my U here becomes what? 0, because this object is coming down. So if my U here is equals to 0, everything here becomes 0. So my H is now equals to half gt squared, right? Because I'm using motion under gravity. And if an object is falling down, U is equals to 0, which is final velocity. Because before an object was projected horizontally, it was at rest before it was moved to go down. Then once it comes down, my U becomes 0 because it was at rest before it started making movements. And A becomes plus G because it is moving towards the acceleration due to gravity. So if that is the case, I have H is equals to half gt squared. So this is for the height, which is the height of the tower where the boy was standing before he made the projection. Now this is the time required for it to reach to the ground. There is one other thing we can ask us to find. If you're asked to find time, you can make T the subject with this equation, right? If I choose to make T the subject with this equation, I will have H is equals to half gt squared. Now, if I do that, can say this is over 1 cross multiply gt squared is equals to what? 2h. I cannot divide both sides by g. I cancel this. So I have t squared is equals to 2h over what? Over g. Therefore, t is equal to root of 2h over g. That is, if you are looking for this time, you can still put in your values and still get your answer by making t the subject, which is the same thing as what I just did, right? Then the next thing I'm going to ask you in this horizontal projection is for you to get the horizontal distance. Now, if you know that speed v is, you can use u here, u is equal to distance over what? Time, right? Is equal to distance over time. But the distance you are considering here is the range. So I will say ut is equal to r over t. Therefore, my range is us what? T. Hope you understand. Velocity or speed is equal to distance over time, right? Now, the distance here, we are considering to be what? The range, which is the horizontal distance from the point of projection to the point where the projectile hit the projection plane again. And over time. Now, if I'm looking for the horizontal distance, which is the range, I'll just say cross multiply. So these are the things you are going to look up for when we are discussing horizontal projection. One is the height, which is the height where the object was projected from. Then the second one is what? Is the time. By making this the subject, we can get that. Then the third one is what? The horizontal distance, which is range. So I'm going to bring up a question, so let's see how we can use this and get whatever thing we are looking for. Those joining us, thank you so much. King Lugard, thank you so much. Adam, thank you so much. I really appreciate. Thank you. Fidem, great. Thank you so much. Alice Daniel, thank you for joining. Prepro Health One, thank you so much. BTS Ocean, thank you so much. Zombie Horror, thank you so much. I really appreciate for your time. Thank you so much. I really appreciate. All right, if you are just joining, please give it a thumbs up. God bless you. I really appreciate it. So let's look at an example of what I just explained. Okay, now let's look at this question. A ball is projected horizontally from the top of a hill with a velocity of 20 meters per second. If it reaches the ground 4 seconds later, what is the height of the hill? A ball is projected horizontally. So the question was specific, horizontally, okay, from top of a hill. That means if this happens to be the hill, the ball was projected from here. Okay, this is the top of the hill. Horizontally, now moves to the ground at a velocity of 20 meters per second, right? If it reaches the ground in 4 seconds later, that is time, what is the height? Now, we are giving acceleration due to gravity as 10 meters per second square. So, the first thing we are going to do is to state our parameters. Now we say my u is equals to 20 meters per second, time is 4 seconds, and g is 10 meters per second square. So we are going to use this formula. H is equals to half gt squared. If you use h is equals to half gt squared, so I have half times my g is constant, which is 10, times my time is 4 squared, right? So h is equals to half times 10 times square of 4 is 16. Now, this is over 1 and this is over 1. So this can cancel by saying 2 into itself 1, 2 into 10, I have what? 5. Then h is equals to 5 times what? 16. And 5 times 16 is going to give me 80 meters. Now, because we are considering horizontal projection, we are not making use of this velocity, but they gave us the velocity because the object was in motion, right? So this is how we can use it to get the height of the hill where the ball was projected from. So let's look at more examples on this horizontal projection. Okay, so let's have okay, let's go again. By having this question, a stone, that should be example 2. A stone is projected horizontally from the top of a tower with a speed of 5 meters per second. It lands on the ground level at a horizontal distance of 20 meters from the foot of the tower. Calculate the height of the tower. All right. So let's solve this question. A stone is projected horizontally from the top of a tower with a speed of 5 meters per second. It lands on the ground level at a horizontal distance of 20 meters from the foot of the tower. Calculate the height of the tower. So I'm going to use illustration to explain this statement so that we can see how we can solve it. Right? Let's dive in. So we have, this is a tower. The object move, right? So the height of a tower is what we're actually looking for. But the object move with a speed of what? 5 meters per second. Now the horizontal distance is range. That means from here to here is giving us 20 meters, right? That is range. So what are we looking for? We are looking for the height. Now there's a relationship between range and the time. Now we are going to look at the parameters given. Okay, let's see the parameters given. You see the parameters given, you can now see how we can solve it. What are the parameters given? Solution. Okay, we are given speed, that is u, which is 5 meters per second. Now we are given the horizontal distance, which is range. Range is giving us 20 meters. What are we looking for? The height. Height of the tower. And g is equal to 10 meters per second squared. Now, one thing will come to your mind. You're looking for height, but we don't even have time. Look at this relationship. That h is equals to half gt squared. There is no way we can look for our height without looking for time. So indirectly, the examiner wants you to solve two different things to solve the time. Then after getting your time, then you now put it here to get your what? The height. That is what they want us to do. So, and there's a relationship between the horizontal distance, which is range, and the time, right? So we see that the range is equals to ux what? T. Ux is because we are considering the horizontal motion. All right. So this my r is equal to what is my u? My u is what? 5. Then my t is what I don't know. Okay, I have my r. Let me put it in. My r is 20 is equals to 5 what? T, right? I divide both sides by what? By 5. This cancels this, right? 5 into itself 1, 5 into 24. So therefore, my time is 4 seconds. Now, if you have gotten time as 4 seconds, we are going to put it here and find our height. Knowing that acceleration due to gravity is constant and is giving us 10 meters per second squared. So we go by saying that h is equals to half times, what is my G? My G is what? 10 times my time. I've already gotten it to be 4. This is 4 squared. All right. So let's go. H is equals to half times 10 times 4 squared is 16. So when you square 4, you're going to get 16. Then what can go? What can go? All right. This can go 2 into itself 1. 2 into 10, I'm going to have what? 5. So this is H is equals to 5 times what? 16. Automatically, when you multiply, my H is equals to 80 meters. Now, you must not forget that the examiner wants you to have the knowledge of horizontal distance, which is range, to use it to connect with your time. Then when you connect with your time, you will now apply it here to solve for your what? For your height. They know too well that you cannot solve for height without getting time. So they want you to get time, then use the formula you have and put it here, then you get your what? You get your height. Is that okay? So let's solve more problems so that you can understand these things better. Okay, Henry, you say you don't understand the horizontal motion. Okay, let me go back and explain the horizontal motion again. I've already explained with the diagram. So let me go back once more and explain the horizontal motion. Please, if you are joining us, just give it a thumbs up. I really appreciate for your time. Thank you so much. God bless you. So let me explain horizontal motion. Okay, so I said before, and I want to explain it again for someone that says he does not understand. For horizontal motion, we are considering from here to here, right? And I say that in horizontal motion, the object is being projected from a certain height. So the object is being projected from a certain height. That means it's no longer the normal projection that we used to do. The normal projection becomes from here to here, right? But for horizontal projection, you must be on a certain object that has height here, so that we consider the height of the tower, the object, the person that wants to project the object is here. Okay, so it's just like half of the horizontal projection motion, projectile motion. Now we are standing here to throw an object. This is out because we're already standing up. So when you throw an object, you are considering just from here to here. And the 3 things you have to consider: 1 is the height, 2 is the time taken for time taken for this object to return to the ground, and 3 becomes the horizontal distance, which is what? Range. Now, and I said that we are going to use using equation of motion under gravity, that is H is equals to ut plus half gt squared. H is equals to ut plus half gt squared. And we are considering horizontal motion, vertical motion under gravity. If an object is going up, it is moving against the force of gravity. A is equals to minus g, and u is equals to 0. But if an object is coming down, it is moving towards the force of gravity. So its A becomes plus g, and sorry, this is b, while this is u equals what? 0. Now, since this object is coming down, the object is coming down, automatically the initial velocity here equals to 0. So that means that my u equals to 0. So if my u is equals to 0, my h be equals to what? Half gt squared. Then my h is equals to half gt squared. So if my h is equals to half gt squared, now I can get my h with this, and I can also get my time with this formula by making t the subject. Okay, that will give me the answer, and that will be t is equals to root of 2h over what? G, right? Okay, now the next thing you are going to be asked to find under this horizontal projection is to get the horizontal distance, and horizontal distance is the same thing as what? Range. It's the same thing as range. Now you know that velocity or speed is equal to distance over what? Time. But here, the distance here is the horizontal distance, and we use it as what? Range, which is r, right? So, but velocity we are looking for here is the horizontal velocity. That is what? Ux is equal to r over t. If I say cross multiply, by making the range the subject, so I will have the range is equal to us what? T. So these are the three things you have to consider under horizontal projection. You can be asked to find the height, like the last question we just saw, but you cannot solve for the height without getting your time. Already they give us the horizontal distance, which is range, and the initial velocity. So if you substitute it into this one, you are going to look for your what? Time. Then you put the time here to get the height. So you should know the whole equation, so that when the examiner wants to trick you, you know how to follow it. You understand? So I'll solve one more question under horizontal projection. Please, if you are joining us, give it a thumbs up. I really appreciate for your time. God bless you. So let's look at the last question for today's class. All right, so let's look at this question together. A stone thrown horizontally from the top of a vertical wall. From the top of a vertical wall. That is, this is a wall and the wall. And this is the top. Okay? This is the top. And this is stone. I will now what? I will now show it. That's what it means. All right. With a velocity of 15 meters per second, hit the horizontal ground at a point 45 meters from the base of the wall. The base of the wall means the horizontal ground. Calculate the height of the wall, and G is giving us 10 meters per second square. Now the first thing we are going to do is to state our parameters. Now we are giving initial velocity U to be 15 meters per second. Then I have the horizontal distance range to be 45 meters. Then I have G to be 10 meters per second square. Now the first thing we are going to do now is to get our time. We are looking for heights, okay? And we don't have time. So what we are going to do now is to use our range and get our time. We say R is equals to UST. Now what's my R? My R is 45 is equals to 15 times T. Then this is equals to 15T. Okay? So 45 is equals to 15T. Then I divide both sides by 15. 15, right? This cancel this to be left with T. To be left with T. 15 into itself 1. 15 into 45, I have what? 3. So the time is 3 seconds. All right. So putting it into our height formula H, we have that H is equals to half GT squared. Okay. What's my, I put in what I have. What's my G? My G is 10. I say 10 times, my time is 3. That is 3 squared, right? Okay, so what can go? 2 can divide this self 1. 2 can divide 10. I'm left with what? 5. So H is equals to 5 times. The square of 3 is equals to 9. That is 3 times 3 is 9. So this is 9. So H is equals to 5 times that is going to give me what? 45 meters. 5 times that is going to give me 45 meters. So this is also another example of motion under of horizontal motion. I hope you understand that. Okay, Henry, sir, why not solve? Why are we not solving with range? Okay, let me bring out question that has range. Okay, let me bring out question that has range. All right, so let me get a question. Henry said I should solve questions that involve range. All right, and if you are considering, I've said it before, if you are considering horizontal projection, range is also the same thing as horizontal distance, right? But if you are considering vertical projection, we don't consider range. But if you are also considering normal projectile or projectile motion, you are considering the height, the time of flight, the time, and also the range. So if you want me to solve question that involves the range, that means I'm going to solve normal projection. So let me solve this problem. Okay, I can say determine the range. Determine, let me just solve for range straight. Then I put in bracket G is equal to okay, so Henry, I believe this is what you mean. Okay, so I want to look at this question and solve for range. Henry said he does not understand. We should solve with range. So I want to solve problem with range. So, but what I was explaining before is this. An object is projected. So the examiner will tell you whether it is projected vertically or horizontally. Okay. So if he did not tell you vertically or horizontally, that means you are doing normal horizontal projection motion. Right? Now, you are now going to look at range. Let's look at this question. A stone is projected at an angle of 60 degrees and initial velocity of 20 meters per second. Determine the range. Now, for us to solve this, we are going to state the parameters. Solution. Theta is 60 degrees. Then we have initial velocity to be 20 meters per second. And we are giving G to be 10 meters per second square, right? Then the formula for our range is this. R is equals to U square sine 2 theta over g. U square sine 2 theta over g. And I said earlier, and I want to repeat myself, that sine 2 theta is the same thing as saying 2 times theta, right? Now, that's what I mean. So let's go. This is, my u is 20 square sine 2 times 60 divided by what? Divided by 10. Okay? So what do I have now? I have r is equals to 20 square, is just like saying 20 times 20, and it's going to give me 400 times sine 2 times 60 is 120 divided by what? Divided by 10. So my r is equals to 400 times, let's get sine 120, that is 0.866 divided by what? By 10. Now, this can cancel this, right? So I have 40 times 0.866. So guess what we have? This is 40 times 0.866, okay? So I have 34.64 meters. 34.64 meters. So the object was projected as an angle. The question did not say, is it vertical, is it horizontal? So it's just normal projection. Okay. So we have the angle 60 degrees, initial velocity 20 meters per second, and we have acceleration due to gravity as 10 meters per second square. So we are using r is equals to u square sine 2 theta over g. Now we substitute it into what we have. We have 20 square sine 2 times 60 all over 10. Then r is equals to, if you square 20, the same thing as saying 20 times 20 to give me 400 sine 120 over 10. All right. Now when you multiply, this is 400 times sine 120 is 0.866 divided by 10. Now this 0 cancels this 0. I am left with 40 times 0.866. By the time I multiply, I'm going to have 34.64 meters. Right? Now, Henry, I believe you'll be able to understand what I just explained. If in any way you still have questions to ask, you can drop it in my comment section, not in this live chat, because I will see it after now. Okay? So if there's any other question you still do not, anything you still do not understand, you still want me to explain, then you can drop it in my normal, on my page, in the comment section, so I can explain that for you. Okay? I'm still going to be live tomorrow by 2 p.m. You can still come up, then ask your question. Is that okay? All right, thank you so much. We have come to the end of today's class. If you have any question, you can drop in the comment section. I'll be live tomorrow too by 2 p.m. Thank you for joining. And if you still want me to teach any topic, if you do not understand in physics, you can drop in my comment section. See you next time in my next class. Bye.